Now the thing is that Z-test will be applicable when the population standard deviation and the average is known to us. But T-test is applicable when the population standard deviation is known to us, but population average or mean is known to us. Because just see in the formula, just like Z value, the T value is getting calculated. Only the sigma has been replaced by S. Only the sigma has been replaced by S. You see, there is no change in the formula. The same formula is there. X bar, sample mean, mu, population mean, S, sample standard deviation, N, sample size, and here also the sample size should be greater than equal to 30. Always remember, we are introducing another term, that is a degrees of freedom. We are introducing another term, that is a degrees of freedom, and that will be always sample size minus 1. So that is a very common question. What is the degrees of freedom? Degrees of freedom means number of samples minus 1 is the degrees of freedom. So that means after selecting one element, how many elements you can select in the sample? Rest n minus 1 number of elements. And that is the degrees of freedom, because first element you can select, and next time how many elements you can select in the sample? N minus 1 number of elements. From there, this particular degrees of freedom, this particular terminology has arrived. Okay, so the same formula for Z test, Z value and T value, but only the sample population standard deviation is replacing the population standard deviation. Find the critical value alpha is equal to 0.05 with degrees of freedom 28 for a right tail test. Find 0.05 column in one tail row and 25 in the left column. The critical value is this. So now we are going to study how to read the T value from the table. How to read the T value from the table. So please please come to the page number 784 of the same book. You are getting the T distribution table. Look at the table how we are doing the same thing. The thing is that degrees of freedom is ranging 1, 2, 3, 4 in this way. We know the degrees of freedom, that is the number of samples minus 1. And along the column heads we are having one tail alpha and two tails alpha. And they are coming like this. So one tail alpha and two tail alpha, they are coming like this. And here you are going to calculate, you are finding out the respective the T value. Okay, now please come to the problem. What is the problem? Find the critical value alpha is equal to 0.05 with degrees of freedom 28 for a right tail T test. So for a right tail T test, so I'm coming down. So these are corresponding data I got. So I'm going for the degrees of freedom 28. So let me come up to the degrees of freedom 28. Page number, what is the page number there? 784. Na? Okay, now see what is happening here. Good. So see, I'm going for the degrees of freedom 28. So 28 is coming like this. 28 is coming like this. So there is a value, that is a 28 is there. There is a 28 is there. So which value should I take? Which value should I take? Here alpha is equal to 0.05. Here alpha is equal to 0.05 and one tailed. That is a right tailed. So alpha is equal to 0.05 and the right tailed. So I'm getting this 1.701. I'm getting this 1.701, and that's why it is taking the right shape. So for the critical value for alpha 0.05 with the degrees of freedom 28 for a right tailed T test. So that's why it is coming like this. So find the 0.05 column in the one tail row and 28 in the left column. The critical value is plus 1.701. So it is coming in this way. So that's why it is coming in this way. Okay, done. So 28 is there and 1.701 is here. So it is coming in this way. So how to find out respective T value? So the same type of formula here is there. A medical investigation claims that the average number of infections per week at a hospital in southwestern Pennsylvania is 16.3. Okay, so the average number of infections per week in a certain hospital is 16.3. A random sample of 10 weeks had a mean number of 17.7 infections. So they are taking samples for the 10 weeks. The sample standard deviation is 1.8. You see, the population standard deviation is absent. So that's why we are bound to do the t-test. Z-test cannot be carried out. Is there enough evidence to reject the investigator's claim at alpha is equal to 0.05? So mu is equal to 16.3 will be my null hypothesis. And alternative hypothesis will be mu is not equal to 16.3. Good. The critical values are 2.262 and minus 2.262 for alpha is equal to 0.05 and degrees of freedom is equal to 9. So now we are going for 0.5, 0.05 and 9. Please come to the... So degrees of freedom is 9 and alpha is equal to 0.05 for the two tail. So I'm getting this particular value. Look at the screen. So here we are having degrees of freedom. Here we are having degrees of freedom is equal to 9. Why degrees of freedom? They are taking 9. Why? Because they have taken samples for 10 weeks. So 10 minus 1. So that will be the degrees of freedom. So that is 2.262. Why? Because they are taking two tail with this particular alpha 0.05. So we are getting the value at the intersection. So that is the respective t value. Now you are putting values in this particular formula and that is the 2.46. So 2.46 is coming in the critical region because 2.262 is the respective thing and 2.46 is falling in the critical region. So I am rejecting this null hypothesis. So I should tell that I am not getting enough evidence to support the null, to accept the null hypothesis, and it is being done in this way. Particular diagram in the page number 431, they are showing that how to read the respective t value from the t distribution. Okay, now they are having some respective problems. I think later you can go through. Going for the chi-square test for the variance or standard deviation. So now the chi-square distribution was used to construct a confidence interval for a single variance or standard deviation. This distribution is also used to test a claim about a single variance or standard deviation. To find the area under the chi-square distribution, the table G in appendix C are the three cases we shall have to consider. Okay, let me come to the respective table. So now see, this is the chi-square distribution, that is the table G, page number 785. So this is the chi-square distribution. What we are having? We are having like your t-test. We are having the degrees of freedom on the row headings, and at the column headings we are having the alpha. We are having the alpha at the column headings. So now we are going to do the calculations on it. So finding the chi-square critical value for a specific alpha when the hypothesis test is right-tailed, when the hypothesis test is left-tailed, and when the hypothesis test is two-tailed. Okay, find the critical chi-square value for 15 degrees of freedom when alpha is equal to 0.05 and test is the right-tailed. So now we are having this alpha is equal to 0.05. So we are having alpha is equal to 0.05. So here the rest part, that is the 0.9500, will be in the non-critical region. Please try to listen to me. So that is the 0.9500 is in the non-critical region, and alpha is equal to 0.05 and degrees of freedom is equal to 15. So now to find alpha value at the top, so how to calculate? We are finding the alpha value at the top and finding the corresponding degrees of freedom in the left column. So that is a 15, and the critical value located where the two columns meet, in this case that is a 24.996. So that is the critical value it is reaching. So see this figure 8.31, we are having this. So 0.05 is the respective alpha value and 15 is the degrees of freedom. We are getting 24.996, and that is the respective values there, and that is in case we are getting this. So as a result of that, now in this case degrees of freedom is equal to 10 and alpha is equal to 0.05 and test is left-tailed. So here we will be having 0.95 and 0.05 is there. So we are getting this particular value accordingly. So it's quite simple to get the value from there. Now if it is two-tailed, and we are having 0.05, so 0.05 confidence level means it has to be divided into two zones. So each zone will be having 0.025 and the respective 0.95 will be there. So here I'll be taking this 0.025. Here I'll be taking the 0.025 and the respective part is 0.95. So degrees of freedom will be has been told here as 22. So we will be calculating the respective chi-square value from the table. Good. Degrees of freedom here they have given only. That means obviously the test has been done on 22, 23 number of sample size. Obviously they are given this one directly. Otherwise from the sample size I shall have to get it done. So there is a formula যেমন করে আমরা পেয়েছিলাম z ভ্যালু বার করেছিলাম t ভ্যালু বার করেছিলাম chi square ভ্যালুটা এখানে দেখো রয়েছে. So now I'll be doing the calculation in this way. টেবিল থেকে পাবো ক্রিটিক্যাল ভ্যালু, সেখান থেকে বুঝবো যে নাল হাইপোথিসিস অ্যাকসেপ্ট হবে কি হবে না. So I'll be getting this one. So let me come one example. চলো আজকে শেষ, আজকে অবধি শেষ, এটা হয়ে যাবে. যদি স্যাম্পলের মিন আর স্ট্যান্ডার্ড ডিভিশন নিয়ে আপনি কাজ করেন, মিন আর স্ট্যান্ডার্ড ডিভিশন দেখুন এটা করছে. দেখুন an instructor wishes to see whether the variation in scores of the 23 students in her class is less than the variance of the population. আপনার পপুলেশন থেকে 23 স্টুডেন্টস কে আপনি সিলেক্ট করেছেন, তাদের ভেরিয়েন্সটা বার করেছেন. An instructor wishes to see whether the variation in the score of the 23 students in her class is less than the variance of the population. The variance of the class is 198. Is there enough evidence to support the claim that the variance of the student is less than the population variance, that is sigma square is equal to 2 to 5. What is sigma? That is the standard deviation. Square of that is known as the variance. তাহলে population variance পেয়েছেন 2 to 3, sorry 2 to 5. আর 23 students এর উপর you have executed the on the sample you have executed the variance calculation and that has been got as 198. So at alpha is equal to 0.05. Assume that the scores are normally distributed. The scores are normally distributed. So now that is the sigma squared is equal to 2 to 5. Suppose a particular school is having 3000 students and they are having their respective scores in a certain exam. You have done the variance calculation on the population. Variance কি করে বার করেছেন is equal to var this range to that range. So we have calculated the variance. What is the variance you are getting? That is 2 to 5. আপনি ওই 3000 ছাত্রছাত্রীর মধ্যে থেকে 23 জনকে নিয়েছেন, নিয়ে সে 23 জনের যে স্কোর তা ভেরিয়েন্স বার করেছেন 198, তাদের ভেরিয়েন্স বার হচ্ছে 198. তাহলে আপনি কি বলবেন যে এই পপুলেশন ভেরিয়েন্স আর এই স্যাম্পল ভেরিয়েন্স দে আর ডিফারিং? তাহলে আমার কি তাহলে পপুলেশন ভেরিয়েন্স ভুলবার হয়েছে? State the hypothesis and identify the claim. So here sigma squared is equal to 2 to 5 because that is a population variance. There is a null hypothesis. And here the variance value is less than 2 to 5. So alternative hypothesis will be sigma square must be less than equal to 2 to 5. Must be less than 2 to 5 and that is a claim. Don't use less than equal to. Less than equal to null hypothesis এর মধ্যে চলে আসছে. So less than. তাহলে আমার এটাটা আমি hypothesis আমি রেখেছি. And now I shall have to judge. Find the critical value since the test is left-tailed. Left-tailed কেন? You know better than me. Left-tailed less than. And alpha is equal to level of significance. সেটা হচ্ছে 0.05. Use the value 1 minus 0.05 is equal to 0.95. তাহলে 0.95 এই প্রবাবিলিটিটা কিসের? নন ক্রিটিক্যাল রিজনে পড়ার। আর 0.05 এই প্রবাবিলিটিটা কিসের? না ক্রিটিক্যাল রিজনে পড়ার। The degrees of freedom is equal to 23 minus 1 is equal to 22. Hence, the critical value is 12.338. Note that the critical region is on the left hand side as shown in this particular figure. So how to get this one? How to get this one? Please let me know the degrees of freedom 22 and alpha 0.05. Okay, good. Now I'll be going for the chi-square table. So I'm going for the 22. Yes, I'm going for the 22. And what is the alpha? 0.05. So I'm going for the 0.05. Yes. So 22 and this one. No. sorry. Now, yes, in the non-critical region, we're having 0.95. So in the 0.95, I'm taking this 0.95 and it is becoming 12.338. So 12.338 has been picked up from the chi-square table. Non-critical bar করব. So that is the 0.95 and there is a 0.05. So that is the margin. So the computed test value using the formula, I'm getting 19.36 and which is coming here. There is more than 12. So it is coming there. So it is coming here. So that's why summarize the result. There is not enough evidence to support the claim that the variance in the test score of the instructor's students is less than the variance of the scores of the population. যেটা claim করেছে that claim should be accepted. The case claim should be accepted.